This might be something that's familiar to you. This is a broken karma test, a broken Angular component test. And if this is the type of thing that you've seen and you've had trouble getting through some of the issues that things like this show, you're in the right place. And someone else had a problem almost exactly like this a few years ago. It was one of our clients who called up and said that she knew how to do some Karma and Jasmine. She understood how those worked. And she was an Angular developer. She knew how components worked. But she had run into problems just like this on her code. See, at her company, they hadn't had a culture of unit testing. So even though she individually knew that unit tests would be really good for her, that it would be good for the application, that she could have a more reliable application, a more reliable project, that she would be more confident in being able to rewrite her code, to do refactorings if she had a unit test suite available, she hadn't actually done it. And so then after the fact, she tried to add some unit tests to her components. And she added the default boilerplate unit tests with test beds and injection and fixtures and all those things that Angular gives us when you start out. And she ran into problems like this. She ran into hurdles. And Angular gives us a lot of power with unit testing, but with that power, there are hurdles that we need to go over. And that's the point of this talk. How do we overcome those hurdles that we run into when we do Angular component testing? So my name is Lance Finney. I'm a software developer, an Angular developer with Oasis Digital. I'm also one of the instructors at Angular Bootcamp. You can see my LinkedIn profile and my Twitter account if you want to follow. I have been with Oasis Digital for about 3 years, and I've been able to write a lot of scalable, robust applications for several different clients that we have because of unit testing. What I'm going to focus on today is a component from the Tour of Heroes. Many of you may be familiar with the Tour of Heroes. It is an application that is built within the Angular tutorial that shows how to start from very simple principles to build up an application that has CRUD features and good backend and a lot of good development principles. When my client asked me for help with her unit testing a while ago, I decided that I wanted to look at Tour of Heroes to see what does it do for unit testing, figuring that since Tour of Heroes is the way that Angular teaches the correct ways to do so many things, that they would show the correct way to do testing. And I was surprised because at that point, the types of failures that my client was getting were the types of failures that the Tour of Heroes had. Because Tour of Heroes, that team, the documentation team, did the same thing that my client did, in that they started out creating the components and it automatically created the unit tests. And then they added everything that they needed to these components, but they didn't update the tests along the way. So the tests had failures, exactly like what I showed before. So I went through the process with her of looking at what it would take for Tour of Heroes to fix things. And that is the process I'm going to go through today. These won't be the exact same failures that you have. If you have issues with dependency injection, there'll be similar things that you have, but not exactly what I show today. But I will show some of the basic things to look at and to think about to get over those hurdles, to get over them. But more importantly, at the end, I'm going to show that you don't always have to go over the hurdle. Sometimes you can go around it, because there are ways to do unit testing, component unit testing in Angular that avoid a lot of the problems if you're writing the right type of test for it. So the Tour of Heroes, the component that I'm going to look at is called the dashboard component. And that is the component that makes up this part, from the top heroes label at the top to these 4 buttons. And then there's a subcomponent with another label and the text field in there. That's the component that we're going to look at. And I mentioned that the Angular team had these tests broken back then. They're fine now. If you download the Tour of Heroes zip file at this point, those tests pass. But in order to be able to talk about them, I stripped that out. I reverted them back to what the boilerplate was, and we'll see what the problems are and build from there. And the first thing I'm going to do is fix the tests. And they do need to be fixed, because this is what happens when I run one of those tests right now. That test fails. And I'm going to talk a lot more about what's going on here and why it fails and how it fails. So I'm going to fix it. I'm going to get this test to green. But I'm going to do more than just fix it. I'm going to expand the test because the initial test doesn't really do anything. It doesn't assert much. I'm going to add some assertions to show why we had to go through that effort, what going over those hurdles bought us, why it was worthwhile. And then I'm going to show that depending upon what type of test you write, you don't need to do that. And if you have the right type of test, and if you divide your tests up in the right way, you can simplify your tests to have tests that run more quickly and make your life a lot easier in the practice. So that's what I'm going to be doing here. Welcome. So let's take a look first at the component and its test. On the right is the component. So this is the TypeScript for the component. It's a fairly small component. There's not a whole lot here, but there's enough here that the boilerplate test fails. If we take a look at it, it has the component decorator, like all Angular components do. And a decorator, the component decorator in particular, does a few things of metadata for Angular. The obvious ones are that it provides the selector, which allows Angular's other components to load in this particular component. It defines the files for the template and the styling that are also part of this component. And then there's the actual content. Oh, sorry. But there's more that the decorator does. And I'm going to talk about that in a bit because the decorator sets things up for our dependency injection, which is really, really powerful, but it's part of what causes some problems with our tests. The component itself doesn't do a whole lot. It has the on-init lifecycle hook. So when it is generated, that function is called. It has a constructor where it takes in a service. And then in the on-init lifecycle hook, which is what's called right here, it calls a function. When we call that method, it uses the service that was injected in the constructor to pull out some heroes. That's really all it's doing. It builds a constructor to give us a service that we use during the ng on init to grab the heroes for display. If we look at, whoops, I clicked the wrong button, sorry. If we look at the template is pretty simple as well. It has that top heroes label that I mentioned. It has some information here. Based on the number of heroes that are in here, it will show a link for each of those, and it has the subcomponent. So let's look at the test. This is, as I said, the default boilerplate test that you get when you create a new component using the Angular CLI. There's one difference though. I added the word F here. So the describe block is what we usually use to group our tests together, to have a test suite of like-minded tests that can share, set up, and tear down and things like that. I added the letter F here to focus in. So this is the only test that will be run. There's other tests in this application, but this is the only one that's going to get run this time because I'm focusing on it. Otherwise, I would just have a describe and all the tests would run. Within my describe, this is the typical structure for a component test. We get a label at the top, which is the name of the component that I want to run. And then it sets up for us by default so a couple before eaches. So these are the code that are initializing things for our component to run the test. I'm going to talk a lot more about what's going on in there because that's where we run into these problems of these hurdles that we need to overcome. And then finally, there's an individual test. That's where our actual assertion is. We say, all right, the dashboard component, it should create. And all we are asserting here, we are expecting that the component instance that was fetched as part of the before eaches exists. That's it. So really all we're doing here is we're testing that the constructor works. And if we look at the test, it doesn't, it fails. So very simple test, and it fails right out of the gate. And this, as I said, is what my client was running into. So what are the problems that we have here? Let's take a look at this. Now, fortunately, most of the Angular issues that you have of this sort give you some pretty good information, but it takes you a little while to get used to them and learn how to read them. This particular error is not a test-specific error. I've run into this error many times as I've built up new components in my production code, and I've referred to a service in a component or a component in another component, and I haven't set everything up yet. This is a production error. And it's such a common production error, actually, that the Angular team, just as part of Angular 11.1, which was just released, made this as part of the initial set of 8 error messages that are keyed in that you can go find more information about easily. And they just released a video explaining more about null injector error. I think it's about a 6-minute video. I'll have a link in my references later. It's a very common error. It's not just for testing, it's also production. So what is happening here? What it's saying, and my cat has joined us, I'm sorry about that. There she is, I'll put her down. We'll see how much she bothers me. What this is saying is when it tries to generate the dashboard component, it runs into a problem because it can't find the other things it needs. And this is something that comes from the fact that Angular has this component decorator. In addition to the things I already talked about, the component decorator is special in that it means not only that the dashboard component can be injected into other things that have an at component decorator or other decorators, but also that Angular will take responsibility for the constructor to inject other things into it. In this particular case, what it means is that we have this constructor running of the hero service. And in our test, we never actually run the constructor. There's no new dashboard component because we're letting Angular do that for us. Angular's dependency injection is taking responsibility for that. And so when we ask it for a dashboard component, it needs to run the constructor. And in order to run the constructor, we are saying, Angular, your dependency injection system is responsible for providing that hero service to us. But Angular doesn't know what the hero service is. So why is that? If we look at the production module, we can see that it doesn't specifically ever mention the hero service in here. So why are we running into a problem when we try to load in the hero service for our test? And the answer is something that you can see in this error message. It's not actually the hero service that's the problem, it's the HTTP client. So what's going on there? So 2 questions. Why does it need HTTP client at all? And then why is it okay in the production but not the test? So let's look at the first question first. So if I go back to this component, what happens is we are telling the Angular dependency injection system, it's up to you to provide for me the hero service that I need. So Angular will go try to create a hero service. Now it can find a hero service because hero service itself has a decorator. It has the special decorator of @injectable. And @injectable is the decorator that we use for services in Angular. It's kind of like a subset of the component decorator. It doesn't interact with all the other files. It doesn't do the selector, but it does mean the same things for dependency injection, that this component can be injected into, this service can be injected into something else, or other things can be injected into it. Further, because it says provided in, it doesn't need to be explicitly mentioned anywhere. Some things in Angular need to be explicitly registered in a module. And in Angular, it used to be true that services needed to be done that way. But since I think Angular 6, most of our services are provided in root, which basically means if anything ever requests a hero service in its constructor as another injectable or a component, just create one and give it to me. And actually, it'll only create one in your entire app. There will just be one, and it's a singleton. So first time, create one and give it to me, and anytime after that, just give me the one that you've already created. So that's what's going on with this error message. It's trying, in order to put in the dashboard component, it's trying to create the hero service, and then it's running into the problem. Because in order to create the hero service, it needs to bring in the HTTP client and the message service. Now, the message service isn't a problem because it also is provided in root. So it is automatically generated without any trouble. But HTTP client is where the problem is. So HTTP client is a service that comes from Angular itself. And Angular has decided not to make the Angular team has decided not to make their services provided in root because they want the Angular initial space to be small, that you need to intentionally add services. So we need to intentionally add that service. Now, if we go back to the production module, where did we add it? Well, we never explicitly provided just HTTP client, but we imported the HTTP client module. And that is a module that includes a lot of things, including HTTP client. And so by importing that into our production module, it was available to our production component. Well, we don't have that production module. We have a special module. So it's not available to our component in our test. And that's what's going on over here in the before eaches. The first before each uses this special part from Angular testing. Testbed comes from Angular core testing to create a module specific to this one test. So we're not using the production module for this test. We're using our own module that is specific only to this test. And when we create it, we configure it according to what is passed into the configure testing module function. And so by default, all it knows, all that Angular sets up when you create one with boilerplate is that it should have the dashboard component declared. And it doesn't know about anything else. It doesn't explicitly know about Hero Service, but Hero Service is automatically provided by provided in, that's fine. But it also doesn't know about HTTP client or HTTP client module. And so we need to tell it to use it here. So we need to set up this component with the things that set up this module with the things that our component will need to know so that our component will be able to run. And if you follow the pattern from the production module, you might think that the first thing that you should do would be to import the HTTP client module. Because that works in production, that's what should work for us in testing, right? Well, almost. It kind of works. But let's go back to our test. So yeah, the test is green now, so it looks like it works. And if you didn't look at the actual console log, you might be tricked into thinking it works. But if we look at the console log, we can see a problem. It's actually trying to make the HTTP call because we're using the real production HTTP client. So real production HTTP client. So that is trying to do the real production HTTP client thing. So we don't want that. We want to use a special one that is only set up for testing that mocks out the real things. Someone asks, there's some questions in the chat. If you have questions that you want me to answer, please put them in the Q&A session in the, sorry, I'm blanking, a Q&A session in Zoom, and then I'll come back to them when I get to Q&A. I'm not gonna have time to really look at chat while I'm going, but if you put it in a question in Q&A, I'll definitely take a look at that. So anyway, back to this. We're using the real HTTP client, so it's trying to make a real call, and we can't do that in our test. Our test is supposed to be isolated from that. Fortunately, Angular gave us a way around that. Instead of using the real HTTP client module, we use the HTTP client testing module. Now this has the exact same shape as the real HTTP client module, but it's set up with a bunch of mocks for testing. There's a whole bunch of stuff you can do with that I'm not going to get into in this session, but there's a lot that you can do to mock out your HTTP calls and see what actually was sent with your HTTP calls, etc. That's beyond the scope of this, but this is the start of what you can do for HTTP testing. And now that I've done that, my test passes and that warning message goes away. There's another warning message down here that I'm going to get to next. Let's ignore that for the moment. But the improvement is that the warning message goes away and my test is green. However, I'm not really happy with this approach. And the reason I'm not happy with the approach for this component test is that this component, if we go back to it, doesn't know anything about HTTP client. The Hero service is what knows about HTTP client. The component itself doesn't. So we are writing a test for the component that has parts of it that depend on the implementation of something else. Well, what if that other thing changes? What if we rewrite Hero service so that it uses WebSockets instead of HTTP? Well, then the unit test for this dashboard component will break, even though the dashboard component, well, nothing within it will have changed. That's a problem. Our unit test should be focused on the code that is in the unit that we're testing, and we should really try to eliminate other dependencies. So this works. This gets us to a green level, but I want to do something more. Now, the problem we get, of course, is that the hero service is what uses the HTTP client. So we need to change out our hero service. Instead of using the real hero service, we want to fake the hero service. So I'm going to show you how to do that, at least in Karma. So I remove that, we come back, and we'll see that we'll get our error again. Okay, actually, other errors, yeah, it just, everything's horrible. What I want to do now is what is the old school way of doing things in Angular with services. So I mentioned before that with provided in, you don't have to explicitly provide a service. This is the way we used to have to do it, and this is the way that we're going to do it here within our test. Now, just doing that, explicitly providing what is implicitly provided, doesn't get us anything, but it's a step in the right direction. Because what we really want to do is provide a copy, a fake, a mock for the service. The code that we have here now is saying, all right, Angular, when my dashboard component loads that I'm declaring here, you have the responsibility that if its constructor includes a hero service, you will provide me the hero service. In this case, it's saying you will provide me the real hero service, but I can use a different syntax to provide a fake hero service. So I'm going to say, all right, Angular dependency injection system, when my component needs a hero service, I want you to provide not the real one, but I want you to use a value. And so Jasmine, which is one of the testing tools that comes by default with an Angular CLI project, Jasmine has a nice utility called create spy object. So this is going to create a fake version of the hero service for us and inject that. So now when our test tries to load the dashboard component, it's going to get here and say, all right, you've asked me for a hero service because that's in your constructor. Instead of giving you the real one, I'm going to give you a fake one. And then with our test, I haven't talked about this before, but the way that this is going to work is it's not just going to be running this one file. It's going to be bringing the TypeScript file and the HTML template file and the CSS styling file. It's going to combine them all together, compile them into a single Angular component, and going to run the lifecycle for us. It's going to do all that for us, which is nice. Then over here in the other part of the for each, we use the fixture as our way to get that fully compiled component out. So we're not going to get the dashboard component itself as just this. We're going to get the fully compiled component that has all the styles and the HTML and everything together. That's what we will get out from our testbed, from our dependency injection. We will be able to then get the individual component out, see if it's truthy, and then the fixture is going to detect changes. So let the change detection cycle finish and settle down. And when we're done with all that, we will have an integrated test, and it's not going to work. It's close. We are in a better shape now, but it's not going to work yet. The reason this doesn't work yet is because of that life cycle that I just talked about. So when we compile the component, it doesn't just call the constructor. The constructor actually passed, but it also called ng on init because that's in the life cycle of the component. And when it calls ng on init, it calls get heroes, which calls the get hero service and tries to call this function. Well, we created this spy here. There's probably not that much in there. Let's see what's actually in there. So I created that, and I can see in the console log here at the bottom, that service is nothing. It doesn't have anything. It doesn't have a get heroes function. So we need to tell this that we want to be calling the get heroes function. Unfortunately, there's an easy way to do that. I kind of hand waved over it, but when I created the spy using the create spy object, the first argument it takes is a string array. And I just put in an empty array because that was just enough to get it to, or an empty string because that was just enough to get it going. But what I really want to put in here is a list of all of the functions that I want this to create for me. And so now when this runs again, it gets a little bit further. It's no longer saying that get heroes is not a function. You can see from the console log that get heroes is a function in this object. So we're further along. But the error that we get now is cannot read property subscribe of undefined. I'm going to call that function on here, get heroes. And you can see that by default, it returns undefined. So we have told our SPY that it needs to have a function for get heroes, but we haven't told it anything that we want it to do. And so in our code, it gets here, it gets to our get heroes, and then it returns an undefined, and it's trying to do observable things on undefined, and that's when it chokes. So we need to change this so that it doesn't just return a object that has a function that doesn't do anything. We need to tell it to do things. So this is going to get a little bit more complicated. So I'm going to extract from here my hero service SPY. And that's what I'm going to use in here. But now I'm going to do some functionality on this. I want to use this SPY to tell it what to do with get heroes. But unfortunately, when I hover over that, you can see that the type it infers is any. It doesn't give me anything. Well, that's unfortunate, but the fortunate thing is that's a very tiny hurdle to get over, because create SPY object is parameterized. I can give it a generic of the type of thing that it is spying for. And now when I hover over it, you can see it's inferring that it is a SPY object of hero service. So now I can come to my hero service SPY, and it has things on it. It knows that it should be able to deal with a get hero, heroes, all these other things. These are functions that are on the actual hero service, and we have told the SPY, these are the things you should be ready for. Without that generic, it wouldn't have worked. So now what I can say is, all right, because I've put this in that array, you have a get heroes function. For that, I want you to return a value, and the value I want you to return is an observable of an empty array. So this of is the simplest way to create an observable. So since the real get heroes returns an observable of an array, I'm going to tell it to return an observable of an array. There's a lot more you can do in here. I don't have time to go into all the things you can do, but this is a simple thing that you can do with that. So now, if we come back to here, we can look at our test. We can see that the service, when it's called, it actually has a heroes, it's actually returning an observable. Our test is green, and we don't have any problems with our hero service. So we have gotten over that major hump. We are using dependency injection from the test perspective to get that information in there. So I'm going to take a little break here. We're not done with fixing things, but I just want to take a break. Just for those of you who didn't come in when I said something earlier, this is not the only webinar we're doing. We have another webinar coming up in a few weeks on NGRX. Right after this session, we're going to have an Angular clinic where if you have any problems with Angular, that you can go ask experts from our company for free advice on how to fix your problems. If you go to oasisdigital.com/training, you can see all of these things, other webinars, meetups, YouTube video sessions, a whole bunch of stuff that we provide. A lot of it's for free. Some of the bigger ones, specifically our training classes, are not free, but a lot of the stuff is free. So getting back to our goal. Remember, our goal is to first fix, then expand and simplify. We have gotten it mostly fixed, well, partially fixed. Things are green. But there's this problem down here that I told you we'd come back to. It's time to come back to it. So what's going on here? It's saying that AppHeroSearch is not a known element. Remember a few minutes ago, then I said that some of these errors, Angular as of the most recent version, will give you the ability to go search on them. That's what I meant here. This NG0304, that's a searchable code now, and you can go find more information and a video on what's going on with this. But what's going on? Why are we getting this AppHeroSearch is not a known element? There's no reference in our code here to anything like that. And we're getting it because, as I said, this isn't just looking at the TypeScript code, it's looking at the entire component. And if we look at the HTML, we have a subcomponent called AppHeroSearch. So this, when it's trying to compile and use the entire component, it's trying to build in even the subcomponents. And in Angular, when you have a component, you need to tell the module what you're doing. And that's what these error messages are here. It says that there are two different ways to fix this problem. I'm actually going to talk about 4 different ways. 2 of them are good, 2 of them are not so good. One of those is really bad. I'll talk through these. The first thing, if AppHeroSearch is an Angular component, and in this case it is, then verify it's part of this module. Well, remember, we're creating a module that's specific only to this test. There's no reference at all to that here. In our actual production module, here's a reference to it. We declared HeroSearch component as part of the production module, so the dashboard component can use it. We don't have anything like that in our testing module. So the simplest way is just to add that declaration. And this works. This solves the problem. I'm not entirely happy with it though, for the same reasons that I wasn't happy with just bringing in the HTTP client module. I'm not happy with this because in both cases, we're allowing dependencies to other things affect our test. So in this particular case, it wasn't a problem. It was easy to add. But what if HeroSearch component had other dependencies? It had subcomponents or brought in other services or something. Now we're responsible for the things that HeroSearch component has in order for this test for something that's not a HeroSearch component to work. That's a bit rough. Now, there are advantages of doing it this way. If you can see under the test bed in this Karma that's running, we actually have the HeroSearch. It got added. We're actually seeing the application run on the fly here. Like we do see the real application here, and that's kind of cool, but it's not worth it for me. So I'm going to take that out and let's look at the other suggestion it gives. The other thing it says is if HeroSearch is a web component, then add this schema to your schemas. So this is for the fact that not all the components in an Angular component need to be from Angular. This is another production feature. Now, most of our components in an Angular application are going to be Angular components, but you can bring in a web component that was written in Stencil or Vue or React or whatever and bring that into your component, and an Angular module won't know anything about it. It'll have no idea how to deal with it. And if that's what you have in your production, then you can add custom element schema to either that component or to the containing module. And we can do the same in our testing module. So if I come over here, I can add the line schemas, custom element schema. And now what that's really doing is saying to our system, hey, if you run across a subcomponent when you're building up this component and it's something that you don't know about, don't worry about it. Don't throw an error. Don't try to bring it in. Just ignore it. We do lose having the component actually brought into our component for testing, but if we're not actually going to do anything with it, that's fine. We don't need it. And so it insulates us from that problem and just removes one of our errors. So this is the approach I like best. There's another approach that is not quite as good, but that you'll sometimes see, where you can put in a different schema called no error schema. And no error schema is similar to custom element schema, except it's a much heavier hammer. And it says, no matter what error you get, if it comes from the template, ignore it. So that can hide actual problems if you're writing a test to actually do something on your template. And so I don't like that. It's a last resort. The video from the Angular team where they talk about this really refers to that as a last resort. They don't even mention the next thing that I'm going to mention because this is a mistake that I made once and I really don't want you to make the mistake. One point when I was looking at these things, I said, you know what? I'm kind of tired of having to bring in all these other declarations and schemas and providers and all of these different things when I'm building up my test module. I've already done that in my production module. Why don't I make use of that? I could just import my actual production module, and then I'll get all of that stuff for free and I won't have to do anything and I can save a good 5 seconds of typing each time. Don't do this. This is a mistake. When I did this before, I added this, and as I said, it saved me a few seconds of typing. But the module that I was bringing in was a large module. It was 50% of a particular application that wasn't particularly well architected. And to load that one module took about half a second, 3/4 of a second, something like that. And the first time I wrote a test, I didn't notice that problem. But it grew into a big problem because what happens is this before each is run before each individual test. And so that was getting loaded every time. The first time I didn't notice the half-second delay, but eventually I wrote a bunch more tests in that file. And then I used that file as a pattern for a bunch of other files. And eventually I was wondering, why are our tests taking 10 minutes to run? And I looked into it, and there wasn't any individual one test that was the problem. It was that every single execution that was running was taking half a second, 3/4 of a second to load a huge amount of our production when our tests were focused on one little bit of our code. So in order to save 5 seconds of typing, I cost myself minutes upon minutes and hours over an extended period of time. And when I took those things out, the running time of the test suite dropped from 10 minutes to 50 seconds. So don't make that mistake. All right, so we have here our test that's working. We have no errors in our console. We have no errors running live. Our tests work. We overcame the hurdles. We overcame the null injector error that was in the hero service to the HTTP client. We figured out how to bring in a spy object to handle that. We dealt with the subcomponent. That's great. So that was a lot of work though. Why is that even necessary? What is that for? So now I'm ready for the second step. I'm going to expand. I'm going to show you what this solves for us, or what this enables. So looking back at our component, I want to write a unit test here. So this component, like looking at the behavior that it has here, this should have heroes. So I'm going to expect that the component heroes length is 4. Because if I look here, this is going to slice out 4 of the heroes from the original array and show them. So I'm going to expect that that has worked. And I'm also going to expect, never mind, I'm not going to do that. So that's why I'm going to test, and my test now fails. And the reason my test now fails is that we're not actually passing any heroes. We're slicing 4 out of 0, and so that doesn't work. So I need to pass in some actual heroes for this to work. Fortunately, in this particular code base, I know that there's an array of heroes that I can use. It has 10 heroes, so that's going to slice out 4 of them. But now this actually brings up another problem. Now that there are actually heroes, there's a problem, another problem in my template. You see here, can't bind to router link since it's not a known property of A. If we look back at my HTML, there's router link. So what's happening is router link is not a built-in part of HTML. It's an Angular thing that works if we have our module set up to be able to use it, but our module doesn't know anything about that. If I look back at the real module, this brings in HTTP router module, which imports router module. So one way to solve this would be to import the production router module. But again, as before, we don't want to use the real production version. We want to use the testing version. And this gives us a whole bunch of power that I'm not going to get into today of things that we can do to mock out routing. And with that, now our test is fine. So this is yet another little hurdle that we had to jump over because of another dependency to set up. But now you can see, like, it's actually loading in the heroes. That's great. Now let's write a test to see that these heroes are in the DOM. And this is where the fixture comes in. So up until this point, the only thing that we have used the fixture for is to get the component out of it, out of the fully compiled version of the component. But I want to write a test now for the DOM, and that is where the fixture comes in. Because this component here, it doesn't show what's on, it doesn't have access to what's on the browser. It really only has access to the TypeScript part of things. But now I want to test stuff from the HTML side, and that's what I need to use the fixture for. So what I want to do is I want to expect that the fixture has 4 of those links in it. Now, there's a lot to this API. I can't explain it all now, but I'm just going to show a little bit of it, that I can query all of that debug element by CSS. And now I need to import the right one. Make sure you import the one from Angular, not the one from Protractor. I want to import CSS and get its length. and I expect that to be 4. So I expect in the DOM, this will actually create 4 of these links, and it has done that, and I have my tests, and everything is good. That's the expand part of this talk. That is why we did this. That is why we had to jump over those hoops. And that is why the Angular community, the Angular team, when you create a CLI, initially gives you the test bed and the fixtures and all of these things. It's so that you can write tests like this. So you can write what they call integration component tests that give you the ability to go into the DOM, into the browser. And if this is the type of test that you want to write, we are done, because we needed to set things up to get to this point. In order to be able to test in the DOM, we need the fixture. In order to have the fixture, we need to have the test bed. In order to have the test bed, we need our dependency injections all set up. We need each of these steps along the way. However, we're now at the simplify phase, because not every test needs something like this. In fact, I'd never write tests like this. I never use the fixture. Because when I want to assert things that are in the DOM, I use Cypress. Could also use Protractor, but personally I use Cypress, which is designed for testing things in the browser. It pops up in the browser, runs the browser, and use them. That's what I use instead. So I would never write that test. So now that I'm not doing that with the fixture, are there ways to simplify that? Yes. So let's look at this test. Before we go further with the simplification, let's take a look. And we can see here that it took 0.085 seconds to run these 2 tests. Remember, 0.085. We'll come back to that. All right. So what are we using this fixture for? Well, before we were using it for both getting the component out of dependency injection and doing the DOM stuff. We're not doing the DOM stuff anymore. We're only using it to get stuff out of dependency injection. Do we need the fixture to do that? Here we are using testbed.create component to get the fixture, and from that getting the instance. Is that the only way to get something out of dependency injection in Angular? No, it isn't. Because I could write this. I could get my service. I could inject the hero service. And there, it will pull the hero service that dependency injection is using out. The thing is, I can do the same thing with the component that I did for that hero service. So we write stuff like this, testbed.inject, a lot for services, but you can also do it for a component. The component decorator is a superset of the injectable decorator. So because you can do it with injectables, you can do it with components. So instead of using the fixture to get the instance out, I can use inject. And then I have an instance of the component that can be used here for my assertions. And then I don't need the fixture. Now, the thing is, when I'm doing this, by not using the fixture, I am no longer using the component and the styling and the template and compiling them all together. So I don't need compile components. Well, and since I'm not doing the template, I don't need to import router testing module, because that was only for the use of router link in the test, in the template. And if I'm not using the template at all, if I'm really only testing the code here that's in the TypeScript, well, I don't need that anymore. And I don't need the schema anymore, because that was, again, only to deal with the subcomponent, but the TypeScript code doesn't know anything about that. I can get rid of that. Look at how much code I've been able to get rid of. Now, there's one other thing I need to do. Here I'm declaring that component as though, actually 2 more things. First, I'm declaring that component as though it were a component. Well, I'm no longer using it as a component. I'm using it as a service. So I put it in the providers array like I do with other services, and now I have access to that. So let's see, does that make our test work? Well, no, our test is broken again. And that's the second thing we have to do. And the reason that our test is broken is that there was one other thing that compiling the component did for us, besides bringing in the different files together, and that was it ran the lifecycle for us. It automatically ran ng on init for us and the other lifecycle events. We've lost that. But fortunately, that's easy to get back, because I can explicitly manually call ng on init. And now all of the same TypeScript code is being called as before, I still have the same test that's asserting all the same things for the test. And instead of taking 0.085 seconds, it took 0.038 seconds and took about half the, well, not half, a lot fewer lines of code. So I showed you before how to get over those hurdles because of dependency injection and all these other things. Now I'm showing you, you can avoid it. Now, again, if you are writing a test that actually uses stuff in the fixture, this is not available to you. You need to go through all of those steps to do things, and you need to bring in your schemas and router testing module and all those other things. But if you're not doing that, if you're really just testing your TypeScript code, you don't need that. You can do this. The thing is, we can even go further though, because we're using this test bed. What are we using it for? We're using it for dependency injection. All right, what is dependency injection doing? It is giving us that hero service. Where's dependency injection getting that hero service? From us. Well, let's just cut out the middleman. Instead of using the dependency injection system to get it, and instead of treating that component as though it's a service, how about I treat that component as though it's a class? Because a component is a class. And now I've gotten rid of even more code, and my running time is 0.22 seconds, about a quarter of the running time of the original way. So if you can, treat your components like a class. If you have any sort of dependency injection, if you're bringing in an activated router, HTTP client, you can't do that because Angular only provides those through dependency injection. So if that's your situation, you can't do it as a class, but you can treat it like a service. So either do it like test it like a class if you can. If you can't do that, test it like a service. And if you can't do that because you really want to test things in the DOM using the fixture, then you have to go over those hurdles. You have to do all of those things that we set up in advance. But you can really simplify your life. This type of testing is called by the Angular team an isolated unit test, an isolated component test. It's a totally valid way of doing it, but they set up the boilerplate using all of the test bed and fixture and all that because the most advanced versions of component testing need it, but you don't always need it. You can make your life easier by testing your component as a component, or sorry, or as a class or as a service when you can. So we fixed the test, we expanded it, we simplified the test greatly. When I went through these steps for one of my old clients, I was able to reduce the running time for one of their test suites from 2 minutes to 7 seconds. It's totally worth it. So that's my talk. That's the webinar. Here are the references. I'm going to tweet out a link to this later so you can grab these URLs from my tweet. My Twitter account is lmfinneycoder. I have the repo, and the repo is what I use here, where I start from scratch, build it up, and then break it back down to the simpler version. I also have a link to the video from the Angular team on the null injector error. So I'd love to know what questions you have for me. And so now I can take a look at the Q&A section. So yeah, please, if you have any other questions, add them to the Q&A section. So first question from Indira, aren't there any global settings or files so all modules required can be imported for all the tests? No, there's not. They intentionally don't do that because they don't want to have you loading in everything for all your modules. They want your modules to be lightweight, to be quick for your users to be able to download them. If they did what you're suggesting, it would really just add a lot of stuff. The closest thing that they have for that is changing how services work by doing the provided in so that they're automatically made available. By making them automatically available like that, by automatically registering, self-registering them, then it is available whenever any service needs it. But then if it's not needed, when it's time to bundle it to send it down to your clients, it will be metaphorically tree shaken. They'll build up a list of all of the dependencies from the root to all of your different components and services and see what actually is used and shake it out. But if you do anything like this to automatically provide your modules, tree shaking will break. All right, next question. We use Cypress to test templates and only unit tests without testing template. Yep, okay. Sometimes unit testing components without testbed and only testing components doesn't show full coverage. And a comment, instable ignore next is needed at the end of the component. Is there another way to have full code coverage on a component without testbed and Istanbul ignore next? The way that the test coverage that I use, I have not seen that problem. So I'm not exactly sure a great answer to you. I have seen things along the lines of like an ng on destroy or one of the lifecycle hooks won't necessarily get called. And so that particular function or method might not be called or show up in the code coverage. Whereas it would be if I use the integration style with the full compile components and all that. But no, I mean, that just tends to be little bits of code, and our system allows, says, all right, that's, 2%, that's fine. So no, I don't have a good answer for that question. I'm sorry. So what is an example of where you would need the fixture, or using Cypress as you describe, eliminate the need for it? Would fixture still be needed for things like components with viewchild? So Cypress solves a lot of the problems. There are specific things that you can do in integration testing with the fixture. As I said, I haven't done much of it because I tend to focus my unit tests for the TypeScript code and then Cypress to do the behavior. You will need to do if you have stuff in there, components with viewchild, you will need to have a more involved system, a more involved dependency injection. You will have to put something in there of your, declaring the other components, because that is actually a runtime dependency of your TypeScript code to have access to that. So yeah, there are times that you will need to bring those things in, but I don't believe that you need the fixture to do that. You could just refer to them in your code. What's the kitty's name? The kitty is Cleo. Hey, Joswell, haven't seen you in a while. How important is to add the correct types to mock service objects versus using any? So I believe what you're asking, and you can clarify if I'm missing it, is what if I hadn't put this in here? This code will work just as well. And if I show you the test will pass, everything's fine. It's not as useful to me, because if I click on here, I do control space to try to get some IntelliSense, and VS Code has no idea what's in there. So if I know exactly what I'm typing, I can get there in the right spot. Everything will work out okay. However, if I put in that typing in there so I get the right thing, now IntelliSense is smarter and I get a lot more help with it. So those are 5 questions that I've had so far. I'm going to take a look at the chat to see if there's anything else. So someone 40 minutes ago asked if you're supposed to be seeing something on the screen. I hope you figured out Zoom and were able to see something on the screen, because I did share quite a bit. As I said, I'm going to tweet this out in just a few minutes. It will have a link to the slides so that from there you can also take a look at get a link to the repo so you can look at the code there and have that example. The video of this webinar will be up sometime soon. I don't know when. There's also a link here to an Angular team video on one of these errors. Any other questions that we have now before we're about to run out of time? Let's see, someone asked a question. Are there any special things that need to be done for testing event-driven code like RxJS subjects or something? Yeah, that is a whole nother topic. So yeah, there are special things that you need to do. Testing observables can be kind of difficult. I'm going to provide a link here. I'm going to show something that I use as a test bed, and it's from my company. So you'll get a chance to see that. That I make use of sometimes. So Angular Bootcamp, as I said, is our 3-day training course, and most of our curriculum is provided for free. If you go to this URL, and I'll put it in, chat. If you go to that URL, you can see most of the curriculum that we do for this class, including some extra things that we often don't get to. And that down here in that area, in step 726, we have an example here that I can click on the StackBlitz link, pop it up in StackBlitz, and then you can see some examples of how of some tests that are written that use fake async and subscribe and a couple different approaches to writing tests for RxJS code. This is only a few examples. It is not a comprehensive discussion about it. It doesn't go into depth on Jasmine marbles and all the other things. If you want to get more of that information, we do have some classes that are specifically on RxJS. We have some classes that are specifically on Angular testing in different ways so that we can go into that in more depth. But at this point in the context of this meeting, all I can basically say is, yeah, there are special things. And I can show you a couple examples. And Joswell answered, do I recommend marble testing for all observable related tests? No, I don't, not for all, because it takes a while to get used to marble testing. And for those of you who have no idea what I'm talking about, I'll pop up an example. So this is just the first blog post that I'm seeing. I've looked at this before. It's a way of writing tests for observables where you can say, I want you starting out with an observable that has this particular shape where it emits hello and then world. I expect that the result of it is going to be something that looks like this. So it's a way of using this mini language to define how your observables and what order they'll be released in and stuff like that. It's very powerful, and there are some things that I have only been able to test that way. But overall, it's more complicated, and I find them harder to read. So usually, I will try to find a way to subscribe to my observable and assert the values that come out of it. If it's a single shot observable, in my test, I might convert it to a promise and then do an async await on that to assert what is in the value that comes out of it. But there are some situations where if you're testing multiple values that are coming through, or if you're testing a stream that has a filter on it, and you want to make sure that nothing ever actually gets emitted from it, things like that, I've only been really ever been able to test it with marbles. So an anonymous attendee added details of the question on Angular Nation PM. I'll take a look at that later. And I think at this point we are out of time. So I hope that everyone got something out of this.